Hi guys, welcome back to SnT Networks. We are back again with the second part of the series, Network Engineer Interview Questions and Answers, Basic to Advanced series. Right. So in today's video, we'll discuss the part two, basically the next few sections on the whole network series. So let's start without wasting any time. So the first question here is explain the difference between public and private addresses. So this is a very basic question, right? But this can also be asked with a few interview folks just to understand the basic knowledge and clarity and understanding of what and how exactly network does things. So explain the difference between public and private address. Basically, in this one, uh, what you have to say is basically public IP addresses, right, are unique. Okay. So there's a difference between public and private addresses. So if I have a network, right, a local network, I usually have a series of 192.168.x.x. For example, usually it's 1.x, but just consider. So this is usually your LAN series, right? This is your private address. But what about the public address? So public address is also a thing, but understand this is your network, this is your gateway router, you have a public IP here, right? And similarly, there is a network here. This will also have public IP. But then again, can these two be same? Your answer should be no. But can these two be same? Can this also be 192 series with probably the same subnet 2424? The answer is yes. Why? Because these are public IP addresses. What you have in your specific network, local network, does not matter, right? That can, because if that was starting to be unique, we would have very limited network devices. We would not have network devices in every home, right? So it's a basic understanding. So public IP addresses will be unique, right? And these addresses are routable in the public internet and are needed for devices to communicate directly to the internet services, internet resources, right? And private IP addresses are reserved basically for use in private networks. Usually these would be in ranges. So private IP addresses are also in ranges. So the range is 10.0.0.0, right? Uh, then we have 172 series, 172.16, and we have 192.168 series. So for private addresses, we have three classes, A, B, and C. Similarly, for even for public total IP addresses, we have five classes, A, B, C, D, E, right? So basically, these are five classes of IP addresses, and out of that, private IP classes we have A, B, and C. Okay. If you want to understand more about this, click on the I button and I have a specific video which will help you regarding the public IP and public and private IP classes. Moving on to the next question, what is a MAC address? How does it differ from an IP address? So see, this we have already discussed once. Let me make this clear. So you have a device here, okay? You have a router here, okay? And this is a device. You have a router here again, okay? So in this case, we are saying that, you know, I when I join this network, this particular network, for example, I get an IP. If this network is 192, I get an IP address of 192. Correct? If I join a different network, this is N1, this is N2, this is 10 series, and I move the same system to here, different network. What will be my IP? In 10 series, definitely. So if you understand simply, the IP addresses keep changing. So they are not uh, basically your permanent address. Okay. So IP address is nothing but a software address which defines you and your location, which is an identity. Simple as that. So consider a simple example. You are at home. Okay. This is your home. Now probably you'll understand. And then you move on to school. Then you move on to college. And there you live in a hostel. But weekly you come back home. So basically on your identity card, your ID, right? Your ID card, you will have something called as permanent address. So in this case, what will be your permanent address? This will be your home. What will be your present address? It will be a hostel, correct? So you can consider your permanent address to be your MAC address, one which does not change, one which never changes, because it's added to your and fixed in your device. Present address is hostel. It can change. You can probably go for a job in a different city. Now you live in a different home. So this is your present address, not a permanent address. Now what is this? This is the IP address. Simply present address will be IP, permanent will be MAC. That's it. If you understand this, done. Okay, now to get in depth, how does it differ from an IP address? You can just say that, you know, uh, in a very simple way, MAC is basically media access control. It's a unique 48-bit or a 64-bit hardware address assigned to basically any network interface card. So, for example, now if you understood this, every device will have, so I have two cards here, NIC cards. Network, this is called NIC, network interface cards. So this will have both an IP address and a MAC address. So every interface IP, MAC. So every interface will have an IP and a MAC address. Okay. And we can say that it is basically added by the manufacturer. So it's permanent. You can't remove it, you can't change it. Okay, it's a physical address. So you can call this as a physical address. And this one is a IP is a software address. Okay. So basically this is the difference. The purpose is basically to identify. Okay. Identify a device on a local network. Okay. While IP address is like identify a device location on network because it's IP is assigned, MAC is inbuilt. Okay. Then you have what is the difference between router and a switch. Okay, well, this is basic, but even experienced folks sometimes will, not answer this really correctly. So this, consider this as a switch. Okay. So switch, you can call it as a broadcasting domain. So why we call it as a broadcasting domain? If I get a packet from here, okay, it will broadcast it in all of its other interfaces. It will not have any exact, you know, uh, routing table, which will help it to make sure to route the traffic directly to one specific interface, for the route propagation. Simple. Now, so this is your basic switch. Now, basically switch, usually we call it layer 2. Layer 2 operates on data link layer. DL layer, it forwards data packets based on MAC addresses. Okay. Switch maintains a MAC access table, not a routing table. Okay. To learn the MAC addresses and forward traffic only to the intended destination port. These are primarily used to create LANs. Now, what do we understand with this? Let me rub this off. Probably now, uh, after we talked about the broadcasting domain, you will get a bit of idea of what exactly am I talking about. If you send a broadcast packet, it will forward it to all its other interfaces and they are sent out. Correct? Now, but now when you're trying to send a unicast traffic, in that case, what happens? This is another. So in switch, MAC address table, by the way, is called as CAM table. For example, if we have a CAM table, this is L1, L2, L3, interface names, okay? Corresponding MAC addresses, I'll write interface L1, L2, L3. This is X1, X2, X3, and this is L4. So now we know that L1, using CAM table, you know that L1 is directly connected to X1. Okay, L1, X1, MAC address. What is the MAC address? We'll let XX, XX, X2, X2, XX2, XX3, X3. Okay, this is XX3, the MAC address. So now it just learns MAC address using whatever traffic propagates. So for example, if somebody tries to send any packets across L4 for X1, so since we don't have a CAM table, now we don't have any entry. For example, CAM table is blank. So it'll go, since it came in through L4, L4 will send it through all its interfaces because in CAM table we don't have entry and it's broadcasting. So it will not drop the packet, but it will send the packet. Now it has sent the packet and only X1 has responded back, for example. So now the switch what will do is it will maintain an cap table stating that if we need to reach X1, the interface must be basically L2. Got it? Now just focus on this part. Let me rub everything off. If you need to use X, this is X1, right? If you L2, if you need to for L2, L2 is connected directly to X1. If you need to reach X1, you need to send traffic via L2, and the MAC address for L2 is uh, X is XX. So next time when a packet comes, similarly next time a packet came basically for L2. Okay, let's draw this back. Yeah, it came again for X1. Okay, this is L2. So now a packet came that I need to go to X1. Packet came, now it will not broadcast it because it has a CAM table. It will just send packet across this. So a CAM table learns IP address in two ways. Okay, IP and MAC, I'm sorry, MAC address in two ways. Basically, one is when traffic propagates through it. Okay, to and fro. Second is there is another feature basically in the MAC addresses. Once the cable is connected directly, it basically sends keep alives to find out what exactly is the next adjacent device. So through that also it learns MAC address in the CAM table. But again, if for even for this there is a default timer after which it expires. Okay, so these are some things you need to keep in mind. The next question we have is what is a routing protocol? Name some common routing protocols. So routing protocol is basically a set of rules a router uses to communicate with each other, exchange information about network topologies. So for example, if we have two networks here, okay, connected, and another network here connected. So now if they have to share information, either internal or external, okay, so they use a thing called routing protocols. How a packet is routed for a packet to reach from A to B. This is B, this is A. It is termed as routing, the way a packet propagates. Okay. And what are the common routing protocols we have? We have RIP, routing information protocol. It's a distance vector protocol. Basically uses hop as the metric. Okay. Then we have OSPF, open shortest path first. It uses Dijkstra algorithm to calculate the shortest path, and it uses cost. Then we have BGP. BGP works between different ASs, anonymous systems, different networks. That is what I mean. And then we have EIGRP. Mainly, you have heard about, EIGRP is a Cisco proprietary distributed vector protocol with features like link state. So this works on link state, and it does uneven routing, right? Even if it's not ECMP. So these are the few routing protocols. Now we have a simple question. What is the difference between static and dynamic routing? Static and dynamic routing. So static routing is basically when network administrators manually configure routing based on table. Okay. Routing table on the router. So you can say that network administrators manually configure routes on the table. So if I have a device here and I want to reach here and I have another device in between. Okay. So if I do a static routing protocol and for example, I have another way. So as per the routing table, probably this would have been my shortest path because of the cost. This is high cost. Okay. So as per the routing protocol, it should go through here. But I can also set a static route telling them that it should reach directly. Okay, so static route is basically suitable for small stable network environments where the changes are not that frequent. It offers more control but requires manual intervention because every time you'll need to create a static route here. It will comprise of destination, gateway, and source, or probably port. That's it. Nothing much. So it basically is sort of like an ACL when you create it. And dynamic routing is basically all of these. Okay, how the routers automatically learn about the network and create the routing table accordingly. This is the dynamic routing. Now, next question: what is a VLAN? Why are VLANs used? Very simple question, very simple answer. If you are in a big company, so VLAN first of all is a virtual local area network. So what a virtual local area network does is it's a logical group of network devices that allows them to communicate as if they are on the same physical LAN, okay, regardless of the physical location. So for example, if I have a switch here, okay, and I have a router, and I have a router, okay, and this is, and I have different departments using this, different resources. So if I, for a very simple example that I learned years back, one is HR, one is IT, right? Other teams using different resources. So these are the servers, okay. So rather than distributing the network as a whole or separating the network, what we do, we create a virtual LAN. So all the users which are, for example, a user has access to both HR and IT. So he'll be added to both the VLAN. So IT is on, for example, VLAN 10 and HR is on VLAN 20. So they get access to both VLAN and they are able to use both the VLANs. So it's sort of like a domain control. You make sure that whatever is in a separate domain has access to only that domain. Okay, so VLAN is basically a way of, you can say that, distributing network using a switch. Okay, uh, and then reasons for using VLAN is improved security, right? We can basically isolate different groups. Then we have increased flexibility, allows for local grouping on devices, right? We have enhanced network optimizations, which is basically simplifies network administrations by creating local segmentations. And then the best is reduced cost, because it can reduce the cost for physical rewiring. You have different networks altogether in a virtual way, right? So this reduce cost significantly. Then we have STP. Why is it necessary? STP is again a very important topic, like we discussed switching, right? Spanning tree protocol is a basic protocol, which is, for example, you have three, you know, first of all, spanning tree protocol is a layer 2 protocol, just like a VLAN. This is again layer 2. So, spanning tree protocol, what this does is, is basically a layer 2 protocol that prevents loop in a network, right? With redundant paths, loop can cause broadcasting domains. So, for example, these are three switches, okay? S1, S2, S3. Now, a switch got a packet. Okay, so it's a broadcasting packet, first of all. Broadcasting packet. So the switch sent it through both the interfaces, here and here. Now S3 got it. From S2 will send again to S3. Now S3's got it, S3 will send again to S1. And then this loop continues. Okay, because even it will throw it out at interfaces, right? Whatever interface is that. This causes a loop. Now to avoid this loop, what we do is we use spanning tree protocol. Spanning tree protocol, what it does is, for example, you know, uh, it creates, it makes sure that if I have a switch here, okay, so I create a root bridge, root port, and designated ports, and a blocking port. So you can click on the I button. I'll probably create a video on this if I haven't. But if you click on the I button, I'll take you to a video wherein I have talked about this a bit in detail and you might get a better understanding on it. So via blocking port, it blocks a significant float. Right, for example, this one. Now this is blocked. So once this is blocked, it won't be able to share packets across. Now because of this, the broadcasting across has stopped. Okay, since the broadcasting has stopped, now even with the broadcasting packets that came in, now one interface has stopped it. So now you will be able to prevent loops because of that. Now it's a thing called root based designated by root ports, designated ports, and what do you call blocking port. So usually only one port will be blocking, and it will again be basically checked by your MAC address and your priority. Okay, these are two things that basically help determining the root bridge and the designated ports. So I'll also create a designated video on this, but for you to understand this, spanning tree protocol is basically a Bluetooth protocol that prevents loops in network topology with redundant paths. Loops can cause broadcasting storms, MAC address instability, and ultimate network. So because of this, what we do is we block a certain port using spanning tree protocol, and it basically helps us prevent loops. There are things like RSTP, which is actually pretty fast as compared to STP. That's it. Right. I hope today's video was a bit quick, right? So you guys don't have to waste a lot of time, and also was a quick recap for you guys. Okay, I hope again this was helpful, and yeah, thank you.